In this explainer video, we'll use Node-RED to improve the integration of a grid supply and a generator on a Victron MultiPlus charger inverter. A MultiPlus has one AC input and cannot normally be smoothly integrated with both a generator and a grid supply. Typically, a generator is connected to a MultiPlus in this configuration. The grid connects to the generator, which has an integrated automatic transfer switch, and the generator is connected to the MultiPlus, which connects onwards to the loads. When the generator is not running, it has the effect of connecting the MultiPlus directly to the grid. And when the generator is running, the MultiPlus is connected directly to the generator. But the problem is that the MultiPlus only has one AC input. And so if the input is configured as grid, when the generator is connected, it shows as grid. And with the generator connected, the input current limit might be set at a high level to suit the grid connection, but we want it at a lower level to suit the generator. And because most Victron grid-connected systems aim to reduce grid usage, we run ESS. When running a generator, we don't want to run ESS optimized mode. We want to run in keep batteries charged mode to ensure that the battery charges as quickly as possible, and we switch the generator off as soon as we can. So how do we make this smoother with Node-RED? Here we have a system that's set up with generator start-stop control already. I'm going to assume that you've set your start and stop thresholds already. This system we're running has a very low state of charge. It's currently running at 19%. And you can see the grid is showing as disconnected. In order to avoid a shutdown, the generator needs to be started soon. Because the system is based on a MultiPlus, we only have the option of configuring one input. The other input is not available, and currently it's set up for grid. Let's improve this by making use of Node-RED. We are going to control this flow using the generator start-stop node as our source of information to control all of the devices. So we drag in a generator start-stop node and we choose generator start-stop state from measurements, and let's name it gen state. We can see that its value types are 0 for stopped, 1 for running, and various other values for warm-up, cool down, etc. We're not worried about the other values for now, only 0 for stopped and 1 for running. We're using a switch node to decide between whether the generator is running or the generator is stopped. 1 for running and 0 for stopped. And I want to point something out here, because this is one of the mistakes that people make with Node-RED flows all the time that can drive you up the wall. As you see it on the screen now, this is not going to work because 1 is not a string, it's a number, and 0 is not a string, it's a number. So it's very important that when you're expecting a number to set the type to a number. Then we're going to label the outputs. Let's label this output as started, and then this one as stopped. So we have the generator state started and the generator state stopped. Then there's 3 parameters we are going to want to change. The first parameter that we want is the AC input 1 current limit via a VE bus system control node. In the drop-down of measurements, we will find the option to change the AC input 1 current limit. So we're going to call that AC1 input current limit. Then the second thing that we want to do is change the AC input 1 source type so we can switch between grid and generator. We are going to do that with a Victron settings control node, and we are going to look in the measurements drop down for the AC input 1 source entry. You're going to see that it wants a 1 for grid and a 2 for genset. 1 for grid and 2 for genset. And we're going to call this AC1 source. 1 for grid, 2 for genset. Then the final thing that we are going to want to do is control the ESS state setting on the GX device. I'm going to choose Venus settings from the ESS menu and choose ESS state. And we're going to name this ESS state. And we are interested in optimize with battery life, which is a 2, and keep batteries charged, which is a 9. So now we have our 3 control nodes in place, and we are now going to want to send the right numbers to them based on whether the generator is started or stopped. So let's start with the input current limit, and let's say that we want 5 amps when the generator is running and 10 amps when it's connected to the grid. And to do that, we're going to add a change node. We're going to call this change node started 5 amps. We're going to change the payload to a number, very important, and we're going to make it 5. We're going to connect that to the input current limit control. Then, if the generator is stopped, we want to increase the input current limit to suit the grid, and we're going to want it to be increased to 10 amps. And we're going to connect it to the same input current limit control. Then we have the AC input source. If the generator is started, we're going to want the source to be generator. We will name it started gen. And we remember that that is a value 2. We can check that now by opening this control node and seeing that genset is at 2. And then if it is stopped, we're going to want this to be grid, and that's a 1. And this is stopped. Right, then the last thing is the ESS state. So if it is started, we're going to want to change that. We'll name this started. Keep batteries charged when the generator is started. And if we remember, keep batteries charged was a 9. Once again, a 9 for keep batteries charged. And if it is stopped, optimized mode, that's a 2. Connect to ESS state and connect that to stopped. So now we should have 1, 2, 3 coming off of started and 1, 2, 3 coming off of stopped. That's exactly what we expect. Started should be 5 amps, stopped should be 10 amps. 5 amps on started and 10 amps on stopped. Perfect. Then started should be the generator type, which is 2, and it's a number. And stopped should be the grid type, which is 1, and it's a number. Then ESS state started should be keep batteries charged, which is a number 9. And stopped should be optimized, which is a number 2. Right, and then we do like to make these things all line up so that the flows look really neat. Perfect. Let's deploy this and see what values we can see. It's currently running as if the grid is present or the grid is disconnected, but the generator is not started. So the generator start-stop state is stopped. The input current limit is currently 10. The AC input 1 source type is set to grid, and the ESS state is optimized. If we have a look at the remote console, we'll see that the grid is showing as disconnected, the battery is extremely low, and we really need to start this generator. So we're going to do a quick manual start but it would have exactly the same effect if it was an automatic start. I'm going to set this to a timed run of 2 minutes. Perfect. Now we still see that the input is disconnected because the generator hasn't warmed up and isn't ready to close its contact yet. But if we look in the node red flow, we can see that the generator state is now running. The input current limit has been dropped to 5. The AC input one source has been set to genset, and the ESS state has been set to keep batteries charged. Let's get the generator connected. The MultiPlus is testing the generator output and is now accepting it on the AC input. We can see on remote console that the input is showing as a generator, and the power from the generator is being used to both supply the loads and charge the battery without the optimized input limiting we'd see if the input type was grid. Now we're going to stop the generator. The grid has returned and we can go back to using the grid. The generator has stopped and the MultiPlus has reconnected to the grid. It's now labeled as grid, the battery is charging and the loads are supplied. And if we look at our node red flow, we can see the generator state is stopped. The input current limit has been increased to 10. The AC input one source is now grid, and the ESS state has been reverted to optimized. So that's how we make a Victron MultiPlus work really nicely with generator and grid when you only have one AC input.